let's start with the introductions. I lead the Lenovo Cloud Technology Center, which is an engineering organization within Lenovo, working with partners, customers, and upstream to deliver solutions in a cloud space, solution being defined as a combination of software and hardware with the Lenovo added innovation. It's a new organization, it's about 2 years old. I will be talking about the work we have been doing in a cloud space. Azar, do you want to introduce yourself?
Thank you, Miro. Hi, I'm Azar Saeed. I'm one of the chief architects in the Red Hat Telco team. We work with our partners to build different solutions for telcos. One of my roles is to bridge that gap between partners and engineering and bridge the gap between customers and engineering. So hopefully we can talk about this NFV solution today.
Sounds good. How many of you work in a telco space or NFV space? I see a couple of hands. What makes NFV solutions different from other private cloud solutions? It's really the workload and the reliability of the infrastructure needed to operate that workload. It's not to say that the private cloud data center infrastructure has to be less reliable, but telcos historically come up with an entirely different level of criteria to create this infrastructure. Both Red Hat and Lenovo has been collaborating for a while with various telcos to try to understand the requirements and the transformation they are going through to transition themselves from the really monolithic hardware-based appliances into the network function virtualization and virtualized infrastructure for their workloads. One thing we are discovering is that the set of challenges and set of questions the customer are dealing with are very similar. There is only so many ways you can really solve the problem, and especially the customers which choose to work with a Red Hat platform as the premier cloud platform for running telco workloads, follow the best practices to implement it and to operate it for their workloads. We have been working on figuring out how to make their life easier, how these various customers can learn from each other, and how they can take advantage of the shared experience we are having working with many of them to deliver the solution faster and better.
Cool, thank you, Miro. So what I'm going to do, first of all, is to lay out the landscape for you. What are some of the challenges? I think Miro described what we are doing with Lenovo to build those type of solutions. But let's first take a step back and understand, why do we need them? What is it that the telcos are really trying to do? What are we trying to build overall? Why do we need them? And what benefit then overall can we provide as a team? So we know that the telco landscape has been changing. We know that it's changing from physical to virtual. We know it's changing from local to cloud. Or we know that now the edge is the new conversation every time we go to a telco. We know that the network infrastructure is also changing. Gone are the days when you were more focused on providing wireline connectivity. Now it's about connectivity in any and every which way. And in fact, connectivity is something that's a given. Intelligence is moving up the chain into the applications. And people are consuming things in very different ways. 10 years ago, before 2007, there was no smartphone. We consume things in very different ways. Today, we consume things in very completely different ways. So the context has changed. The telcos have an infrastructure that they need to evolve with the consumptions of people and build, package new services. So they have to really move faster. So those set of challenges within, if you can actually bucketize those set of challenges for telcos, reducing costs for them is imperative. They can't just build out the infrastructure multiple number of times over and over again. They can't just keep investing on the infrastructure again and again. They have to move at it in a different way. They have to look at and tackle the problem in a different way. Modernizing the existing networks, not just your data center, but also your IT infrastructure and your network infrastructure. Why do they want to do that? Because they want to move much faster. If they don't do it, what happens? The over-the-top players take it, right? If you remember the big lawsuit that happened between Netflix, Comcast, and Level 3 at that time, what was that about? It was about essentially Comcast asking for a share of the revenue from Netflix and Level 3. Level 3 is the content provider for Netflix. Netflix is a content provider. Level 3 is a distributor of that particular content through the national backbone. And what happens is in the evening, you could see network stats on Comcast. After 5 p.m., it just spikes up continuously. Who's going to invest the money to build that last mile infrastructure to add more capacity to the Comcast network when Comcast is not getting a penny out of it? Comcast is charging you flat for your home internet connection, but they're not getting any penny of the... So the over-the-top players chewed bandwidth, chewed infrastructure in very different ways, where you and I are consuming that particular content in that manner. But the revenue share is not really going appropriately. Of course, it was later that they came to an agreement in terms of how to settle that. That's a different story. But that's what's happening to infrastructure providers, to the infrastructure players, that they have to figure out a way to invest, they have to figure out a way to monetize, and how do they monetize that better? Now, open source, the other thing that is happening is innovation is being driven through open source. There are various different open source communities that have come up with many different open source projects. While open source makes it easier for people to actually contribute and to adopt, but you have to be in the community to understand what's going on. Surely, the goal of the open source is to make it cheaper, because you no longer have the licensing agreements that are associated with typical, vendor proprietary stuff. So, what you do pay for in the open source case is mostly support costs, because the software itself is free. So that has attracted telcos quite a bit in terms of how can they reduce that particular cost model that they have. How can they change that particular cost model? How can they go? Now, open source is not, it doesn't, come for free in the sense that you have to really understand what's going on. No one community will provide the entire solution for you. You might have to actually pick different communities of open source to build a solution that you want to be able to build. So that becomes now a different type of a challenge for telcos. Open source is great. Red Hat is a pioneer of open source. Red Hat always preaches open source and upstream first. And I'm sure you heard that through the keynotes as well. Now, all of these open source communities that you see here, in some way, shape, or form, are relevant to a telco. Open Daylight as an SDN controller, Kubernetes as your container orchestrator, OpenStack as your infra manager, Hadoop as your big data solution, right? You'll see something on the right there called Metaswitch and Clearwater. Those are kind of mobile functions for IMS if you're going to try to deploy mobile NFV for mobile networks and so on. And then there are other areas like ONAP for orchestration, telecom infrastructure projects. So lots and lots of effort in general going on and moving at a really, really fast pace in terms of innovation that's taking place. So what should the industry do? Well, the telco industry needs to really look at that and say, how can I leverage this? How can I leverage the pace of this change? How can I adopt that particular change into my environment? And how can I make myself more agile? They have to figure out a way to standardize their platform. They have to figure out a way to automate that particular platform. Obviously, NFV and SDN stuff can help them take a long way, but that's just not enough. They have to also look at what their processes are, how their applications are evolving, how can they build more cloud native type of capability, how can they refactor or retool their back end, retool their front end to be able to leverage the power of these communities and build different types of solutions. So that's how telcos really need to respond. So one of the key bullets out there is network function virtualization. Network function virtualization has really changed how telcos look at their network infrastructure. Originally, a paper was published way back by Etsy And they put out an architecture saying, this is my framework architecture for NFV. And the idea was primarily to drive the movement away from proprietary hardware and proprietary software to open software and Intel-based hardware or open hardware. And to take those functions, virtualize them, run them as applications on top of Intel infrastructure. Now, of course, initially the industry faced with a lot of challenges with respect to performance, with respect to how much data throughput can you achieve out of an Intel server, when my dedicated machines could achieve far more scalability or far more. But now, 2 years, 3 years down the line, things have changed considerably. Now you can expect very high performance. In fact, Miro would go into some of that information later on in this presentation in terms of what they have done to actually improve this. So performance is no longer that much of an issue. Well, it may still be in terms of how many cores are attached and so on and so forth, but significant progress is being made. Smart NICs have come around to actually put a new face in terms of how you'd utilize Intel infrastructure for packet forwarding. So that has happened. So this revolution has really taken off in the industry. Most of the providers that I talk to have either some plan or already are building a plan, or some have it, many of them have it in production, this whole NFV environment. And in that NFV environment, some of the key components are things like OpenStack, things like OpenShift, right? Container management, virtual machine management, IaaS infrastructure, and then various different VNFs that have different performance characteristics and capabilities that are put on top and integrated together to build that particular VNF solution. Where is NFV being used? Well, multitude of use cases, right? Each use case, if you actually look at it from the, let me just go around on this slide. If you can talk about 5G for NG core, or you can talk about 4G for virtual EPC, all of them, they're all virtualized components now. 5G is still not there yet, it's probably coming, but it's certainly something, the whole 5G architecture is built around cloud native model. And cloud native model means, virtualized, containerized, microservices, etc. Right? So that's happening in that space. Where LTE today is being deployed in terms of the packet core gateways or network functions, all virtualized. Similarly, RAN, radio access network, that's being virtualized as well. So what is happening is the radio functions that were now split in antennas and E-node Bs for LTE are now being completely split apart with radio functions, passive antennas, and some active components where you maintain the PHY layer and then you put control plane actually in a general purpose compute infrastructure. So that revolution has already happened, and people are beginning to use that to build better low latency type of services for mobile, in mobile context. So that's the CRAN piece that you see. That's the other use case. Branch office changes and simplifications where you're collapsing multiple different types of machines, servers, bare metal, dedicated hardware into simple virtualized pods or simple virtualized, small half rack type of an equipment where everything is running as a virtualized solution on top of that. So that's the branch office, consolidation scenario. Residential services, where residential services were previously being terminated on dedicated boxes with broadband network gateways, BNGs, and with lots and lots of hardware gear that used to sit in a central office or the local POP. That is now all moving to a virtualized environment. All the residential services that are being terminated from how you consume your internet service, you don't see a change, but at the back end, everything's being changed. So in that context, what people are really trying to build is what is called as a virtualized central office architecture. And with Lenovo, actually, we did a very interesting demo last OPNFV Summit in Beijing, where Lenovo hosted a full central office architecture, fully virtualized with OCP compute gear, and we demonstrated both residential and business services on that using Red Hat OpenStack platform and Lenovo hardware with white box switching, complete fabric. It is a wonderful piece of, there are many demos. If you just go to opnfv.org and search for VCO, you will find actually a very detailed presentation, a demo, and the entire architecture and the white paper and all of that. So that's what is really happening in terms of a change with respect to the providers. Now, we know that from a provider's perspective, it's not enough to just look at network. It's also important for you to look at what the back end is, how you're managing data, how you're managing your applications, and can you build a common infrastructure? Can you build a common platform that allows you to then build these type of network services on top of them, put data management capability with it, leverage all of the power of open source communities, create a complete solution end to end, right? That delivers that service that you need to deliver from a service provider, from a telco point of view. And that's what this particular architecture looks like. So here's your network infrastructure platform with all of your VNFs, your assurance and monitoring capabilities, and so on. This one, the example that was taken here is essentially for mobile, but you can put this example also for wireline or business. Here's what you see is in terms of various different tools and components that Red Hat provides with respect to middleware that creates the binding glue between your network layer and your application layer. And that you can then derive data from the infrastructure. You can do event processing, you can consume that, and you can you apply analytics, you apply AI capabilities, create a closed-loop feedback control system back to the infrastructure so that you can automate that particular process and actually completely modernize and revolutionize in terms of how you do that. And then same thing, applications need to be tied in, and with that you can create it on a common infrastructure, automate that whole thing. So that's the kind of solution that service providers or telcos are really looking for. However, one thing we have to understand is this all means that previously you had consumed software and hardware together as a single package, and everybody looked at the bright lights that shined on that hardware. Right? That's how you consumed it, that's how you ran it, that was the way. Things have changed. Well, everything is now disaggregated. When you disaggregate, you have opportunity to combine or recombine in new different ways, to create new solutions, to create better agility, to create independent modules. So it provides you, disaggregation implies greater flexibility. However, greater flexibility also implies there are many ways to come up with a solution for the same problem. But when you do that, what happens? Complexity increases. When complexity increases, what's the thing that has to follow through with it? You have to provide some level of integration capabilities. Take the pain out of that complexity in terms of how you go deploy, how you go deliver. So that's exactly what this chart is trying to show. Unbundling from monolith is disaggregation. You create these set of components. Those components then have an independent life. It becomes incredibly flexible for you to pick those different microservices that are available, pick those different components that are available, stitch together a solution, and anybody can do it with some level of expertise, right? So you can create different variations of those different solutions. However, in order to consume those different variations, somebody needs to take the pain out of integrating them, building them, and delivering them. So that's what Miro is going to talk about in terms of how you can take that particular cloud challenge and apply it in terms of a solution.
Thank you. I make two comments. As I mentioned, blinking lights. There's something about blinking lights in data center. People really like it. We have a rag in our booth, and people just often stop by just because the blinking light attract their attention. The second one is, if you hope that I'll start with the answer of how to simplify it, let me make the story a little bit more difficult, actually. The complexity doesn't end with the software. The major expense in building the infrastructure is actually getting the physical infrastructure in place, and they're operating over time. As you're probably aware, the telco environments are actually fairly complex. You have a very complex structure of deployment, starting from core data center to regional data center to branch offices to radio access tower, all the way to the premise. You have to think about all aspects of the infrastructure, both the server, the networking, and the processes to put it in place, maintain, operate, or renew over time. And the software vendors providing the elements running on this infrastructure often really think only about the way how to make your life easier to get that infrastructure in place, how to deploy it, maybe how to update it. The life of the infrastructure actually starts way ahead of it. You start with the certification process, where you get the samples, the POCs in your lab, you kick the tires of the gear. Then you have to go through the procurement process, and the delivery, where it often can take months to manufacture equipment, get it in the right place in the world, get it racked and stacked, get it operational. You deploy the software platform on it, you go through some testing, certification, make it operational, and then your workload actually changes because there is a new service which a content provider came up with, which may require a different mix of infrastructure in place. You may need to go through the reconfiguration. Or there may be a new, more efficient platform. You have to transition from a virtual machine to containers, where the structure, configuration of the information made to morph over time to support a different workloads. And telcos, the communication providers, also are sensitive operation. You have to have a proper processes in place to remove and destroy the infrastructure after the time. So when you're thinking about your telco NFV solution, you have to not only think about the complexity, getting the right software platform in place, but also the processes and the hardware platform running on it. As I mentioned, some of the previous efforts Red Hat and Lenovo have been collaborating over the last couple of years. We've been participating in ETSIC Plugfest, NFV Plugfest, where the vendors from the industry get together. They bring the hardware, so components together, and they test each other. They test interoperability, they test the best practices, they provide a set of blueprints, how to operate this infrastructure. And one of the common themes is that the structure of the infrastructure which the solution is deploying is fairly similar. You always have to have top-of-the-rack networking. You have to have some control plane providing a control function of the infrastructure. And then you combine some building blocks to match your workloads. You need compute, you need storage. Sometimes because you are in a constrained environment, the branch office, you have to compress the compute and storage together in a hyperconverged solution. You may need dedicated storage for archival functions or for logging or content delivery. And often you need to provide the acceleration for those workloads. And everybody's asking for the same kind of things. You want this infrastructure to be easy to acquire, easy to assemble, easy to operate. And in today's world, the public cloud is the benchmark. It's no longer various hardware vendors competing between each other to say who can deliver a better server. It's really the benchmark for the architects and developers is how do you compare to the public cloud experience where I can get the new service or the new capacity at a swipe of the credit card or signing of the contract. It's available to us. Oops. Yeah. Here we go. We saw a previous slide of the entire portfolio of Red Hat products. And Red Hat created a reference architecture of how to combine the portfolio of products to deliver, to implement the ETSI blueprints using the various functions the product provides. The way the portfolio really splits is three elements. There is the platform group of products, such as RHEL, OpenStack, OpenShift, to provide a foundation, the NFV layer, for running the workloads. There is the control of the management functions, such as CloudForm, Ansible, Insight, to provide a way to easily operate those platforms. And there is a set of products, such as JBoss, EAP, to provide the workloads to run actually on this platform. If a telco provider or communication service provider decided to use or to collaborate with Red Hat to implement their platform, the answers are often very similar. They have to really understand the best way to implement the platform layer and how to best put in place the management functions to operate this infrastructure. And in today's world, everybody's asking for support of multiple hardware platforms using common standards such as Redfish to integrate into this infrastructure. So we have looked at it, talked to many of the partners and customers, and said, what if we take a different approach to assembling a solution based on this common understanding of the process, how the platform needs to be put together by the software which runs on this platform, and the various building blocks to construct this platform from. We can then use this architecture and this process to deliver solution for a core data center, where the solution has to scale to hundreds of nodes. We can deliver this platform to a branch office, where you have a one rack of servers need to provide both the compute and storage functions and everything in between. And the way we approach this, we really split it into kind of three trenches. The first is the intelligent management and automation, which is all the functions which are needed to operate this platform. And you can see the portfolio of the products. I think the slide is a little bit corrupted, but basically the functions you need to put in place is a hardware manager to operate and hardware to get the events out of the hardware to the rest of the platform, the software manager to manage the delivery of the bits to the platform as they need to be updated over time. First deployed, then consumer upgrades or security fixes. You need a workflow automation because nobody does things manually anymore. You respond to the events in an automated fashion to a self-healing and maintenance. You need a storage management, and then you need a platform to support various kinds of workloads. Bare metal Linux for bare metal workloads, virtualized or container workloads. You need a place to run your workloads, which would be the cloud-ready node in those three form factors I have described, together with a hyperconverged option. And then you also need dedicated storage. And storage doesn't really come only with the products which Red Hat has in the portfolio using Ceph or Gluster, but as a CSPs, you have lots of data in place, you have lots of experience in place to operate the data platform, and therefore you are asking for a way to integrate a traditional SANs or fiber channel into your architecture to provide the storage backend. In addition, you often have a need for a platform multitenancy. So you are not only asking to operate an OpenStack and all the workloads running in OpenStack. You may be going through transition where some of your workload required OpenStack, but some of the workloads are already containerized and running on OpenShift. Depending on the VNFs, some of the VNFs might be certified against a particular version of the OpenStack. So you may be already operating VNFs which are running on version 10, while you have Red Hat is releasing the version 13, and VNFs are soon starting to get certified against OpenStack 14. And therefore, you may need to run multiple versions of OpenStack in parallel on this platform. And what telcos are also doing, they're also looking at how to use the common architecture and common set of components to operate both the carrier side of the business and the IT side of the business. Mm-hmm. And often on in the labs or in the test environment, you may have a need for multi-tenancy where the same environments might be shared between certification of various use cases. What we've done with Red Hat is we take the experience working with the customers and partners, and we have took the Red Hat Cloud Suite of products and built it into a simple to consume and deploy an appliance. We call this appliance a brain, which is there to simplify the deployment and provisioning of the infrastructure. It includes all the capabilities of the Red Hat portfolio, pre-configured, pre-integrated, tuned, and automated for the common deployment scenario. It's really the foundation for the telco and DevOps workloads. The particular form factor on this picture is actually 4 servers in a 2U, so it's suitable for deploying in really a branch office, very limited space, as well as in a central office where it can scale to additional to support the additional load. And because we are working at the Blackfest and in our labs with the various VNF vendors, we provide a configuration files, templates to deploy and tune for the common VNF use cases. Obviously, you will not run your carrier workloads on this to your appliance. What we really do is we enable the entire portfolio of our hardware to be easily attached to this appliance to really create your cloud environment. Depending on the type of the workload, you can choose a dense compute, really optimized for the compute memory consumption, or you can choose a storage-heavy server. The servers get automatically discovered by the appliance, gets automatically provisioned on the fly to the right configuration, where you can select, is this going to be a OpenStack hypervisor node? Is it going to be a self-storage node, OpenShift worker node? And based on the configuration of the server, they get applied a tuning for a given use case. So the configuration files takes into account a NUMA PCI topology, apply, let's say, CPU pinning, and put in place the right drivers, for example, for the SmartNICs. In addition to the servers, the storage portfolio is also integrated to the platform. It really allows you to then, such as Lego blocks, really pick and choose the right hardware, the right combination of the configuration, without really having to spend too much time thinking about how to put in place the control and management function to deploy and operate this infrastructure. And then it allows you to really move to the part of the business which you should be focusing is really working with the application, with the workloads, with the VNFs, to putting together the pipeline to implement the virtualized network functions. In addition to the Red Hat Cloud portfolio of products, we have added a set of additions which we are working with Red Hat upstream to make the experience and consumption easier. We subscribe to the upstream first mantra, and this is one of the examples which we are working on, but which is in a ManageIQ product, where the CloudForms or the ManageIQ project has a very good implementation and visibility of the various layers of the functions from the platform, which is the hypervisor app. You can see the hypervisor, you can see the VMs or containers running on it. You can see the workloads in those containers in a single pane of glass. Until recently, you have had no visibility into the physical infrastructure. As Chris Wright mentioned today in the keynote, Red Hat and Lenovo have collaborated in the ManageIQ project to define and implement a first physical infrastructure provider, where it makes the physical infrastructure, your server layer, visible side by side with your software infrastructure. That work has been done upstream in a ManageIQ project and then trickle in to the latest release of the CloudForms. So in the CloudForms 4.6, you can see your physical server side by side. We are now working on the next steps, where we have completed the design for a physical networking. And we are currently working in an upstream project on implementation of the physical networking, that you will be able to see your switches side by side with your servers. You will be able to see the relationship and cross connections between your server ports and the switch ports to have a full visibility of the networking in the single pane of glass. And our plan is to then extend and complete the loop to work on the physical storage framework. So if you are interested in collaborating, either as a customer, having a specific use cases in mind which you like to see, I invite you to reach out or come to the community and participate. This is just one of the very specific examples. You can think about others which are delivered as part of the platform, which is a native OpenStack hardware platform integration through our Ironic driver. We have a storage console allowing easier provisioning of the Ceph infrastructure, and open control-based SDN controller, which provides a alternative to the open daylight software-defined networking delivered by Red Hat. So to close the topic, I think there's lots of exciting things happening between two of our partners in making the building both telco and non-telco infrastructure easier, so we can get to the next things, which is really focusing on the optimal way to construct the workloads. If you are interested in,
yeah, I think Miro, you said it really well. Although I focused mostly on the telco use cases in the beginning, you can apply what Lenovo has done with the Red Hat software in any context, in an enterprise data center context, in a branch office context, in a telco context, because what they have done is actually pre-integrated those software suite for you to be able to consume and make that much easier. And that's kind of the critical piece that we started off with the value prop that says, okay, all these open source communities, all these projects, all these different things that are happening, how do I make that easier for people to adopt? And this is the effort.
That's correct.